Okay. Okay. Could you please, answer the question? What
Mute?
is?
Oh, sorry.
Hello.
Sorry, did you
Yeah.
want me to mute?
Yeah.
Oh.
Please answer the
Oh,
question.
okay, sorry.
Yeah. Hello. Could you please answer the question? What is data analytics or data analysis?
Sorry, sir, you're cutting off. I have no idea what you're saying.
Even the this thing is off. Camera is off. I don't know why.
Can you hear me?
Yeah, I can hear you very clearly. No problem.
Okay. Okay, now you were breaking before that. So what was your question?
What is a data analysis or data analytics?
Well, data analysis, I know you said now it's a process of collecting, cleaning, organizing, and examining data to discover useful like information, patterns, and trends. It helps businesses make informed decisions based on facts instead of guesses.
Perfect.
And, yeah.
That's perfect. That's perfect.
That's
Now, why I'm repeating these things, because now we're going to see this data analysis in a new light. Okay. In the sense, data retrieval, we retrieve data. Data
yeah.
preparation, we do data preparation. We do data cleaning, data modeling,
Exactly.
and we present the data as a kind of solution. Okay. So this way, just give me a minute, please. I don't know. Just give me a minute. Yeah, pardon me for that. So overall, we have these 5 distinct steps. So we might say capture, process, store, analyze, use. Okay. Now, here, what these guys, really compare these steps with, in terms of, if you want to really use technicality in the terms like capture. So what is capture? You retrieve the data from a given location. You try to ingest the data at any scale, be it a small, like, a couple of MB, be it large, like a couple of petabytes. And these things do happen in real life. Okay, so we need to cope up with these things. So capture is basically we are getting the data in our hand for at our disposal for all these preparation, processing, and then we store this data. What we do, we normally make a copy of this data, because whenever you are trying to do analysis, you might delete, modify, or do some processing on that data, which make the data differ in terms of whatever we got and whatever we have. So if you need to retrieve some original terms, original data points, original data elements, we might need to retrieve it from the backup rather than retrieving again and again, because these retrieval authentication authorizations will be given to you for certain limited time in most of the companies, because they store their data as an, it's a very critical asset for a company, right? Be it something like MIS data, the employee attendance data, employee salary data, be it something like, data of their client, which you need to process for a solutioning, right? So the data is really a critical asset for a given company in any scenario. So that's why whenever you retrieve data, you make another copy of it to, do the processing, cleaning, deleting, modeling, remodeling, and all those things. So that's why storage of data is also an important part. So you might create a data lake. Data lake is just a data view. Whatever you update will be updated in view only unless you commit that data to a store. Again, these are a bit of technical term in terms of data warehousing. Data warehousing is a terminology which you use wherever you store your data, and it's called as a warehouse. Warehouse in the sense you store your things, right? The Amazon warehouse, be it another warehouse and something like that. So what you do, warehouse, you keep the things. Whenever you want to use it, you retrieve it from there. Okay, as simple as that word says. So here we are using data warehouse. So where we store the data, we keep another copy of data safe, whatever we retrieve, and we process on the data which is we copied. We make another copy of data and start working on it. Whatever data cleaning, deleting, deleting the blank rows, blank columns, blank records, blank categories, and blah blah things. And we do analyze this thing. So based on data warehouse, wherever you store this data, because nowadays we really work on very ample volume of data, big volumes of data. So that's why we need to have certain data storing mechanisms. So that's why we refer our data storage as a data warehouse, and there we normally process our analysis. Okay, and then whatever presentation we do, whatever use that advanced solution you make, something like business insight, something like a really critical data process to be shared with the top managers, top bosses, or the business people. Here we use that data warehousing to provide our advanced analytics from there. So this data warehouse is a kind of entity which helps us to have a data retrieval, data copying, and all these processes much faster, much efficient. So that's why we normally have these data analytics 5 step. Again, some might have 4, some might have 8, depending upon your thought process you're learning. But I believe 5 is good figure to explain to interviewer what you mean by data analytics or data analysis. Does that make sense? Any questions on these?
No.
Okay, we good, right? Now let's go ahead. Now let me try to share with you. There are 5 distinctive type of this analysis we do. In terms of the way we've matured in our analytical processes, we categorically differentiate 5 types of analysis. Again, these are independent. The way shown in progression in terms of difficulty, but not in terms of how they have been evolved. Okay, so there is a descriptive analysis. So as the name suggests, you have to describe the data in terms of what type of data we have. So we might say, it ranges from this to that, between this and that, and so on and so forth. This is the kind of simplistic descriptive analytics we using. Again, as we have data, as we have numbers, there is a maths involved here. So why we have maths involved? Because here we're utilizing some part of mathematics in terms of range, in terms of how much is the range, how big is the volume, what kind of median, average are we looking for, and so on and so forth. So that's why we have these 4 distinctive type of analytics which we normally discuss whenever it comes to presenting our data to the business people. And business people do understand these basic you might say statistical terms. Statistics is a branch of mathematics which is we are utilizing here for our own use, to have a common explanation, to have a common technical terminology to be used with the business people, research people, and so on and so forth. So first we have descriptive analysis. So we are just describing it. Then we have diagnostic analysis, where there's a bit of calculation involved. So we are diagnosing something. If you diagnose a person, what do? You try to probe it, right? You try to take the temperature, take the ECG, heartbeat, BP, and there are a number of things. Similarly, in mathematics, in terms of data analytics, you do diagnose data in terms of, do we have any spatial ranges? Do we have out of range numbers? Do we have maximum, minimum numbers? So is the maximum number within our range, or our range needs to be updated? Are there any exceptions? So what kind of exception are we looking for? How the exception differs from the mean, the median number, middle numbers, and so on and so forth. So these are kind of probing the numbers, right? So we are trying to analyze the data in terms of mathematical terminology, like the range, the outer range, the exceptions, and so on and so forth. The next step in terms of complexity or difficulties, predictive analysis. And this is really growing fast. One of the most important terminology as of today in terms of solution making, be it a data analysis, be it a data scientist. Here, we are trying to showcase the predictiveness of maths. So what is the predictiveness of maths? Let's say a kid is growing, right? So infant gets born. So his age is like 1 month, 2 months, 3 months, then 1 year, 2 year, 3 year, 4 year, 5 years, and so on and so forth. This is a kind of and he'll grow year by year, as simple as that. So this is how the maths guide us, how we can analyze the trend in maths. So what are the trends? Let's say a child born in 2000, 2K, will be of the age of 3 into 203. As simple as that. It will the age of 6 at 206 and so on and so forth. This is the tendency of mathematical, progression. Okay. So what we are trying to say here, whenever the child grows, he'll be, if it's 2K born in 2000, he'll be at 24 years of age in 2024. 25 years of age in 2025, and so on and so forth. So he'll grow with the time. And this is what the predictive analysis basics are all about. So what you're trying to say, if somebody have a sales figure of 10 in the first month, 12 in the second month, 15 in the third month, and so on and so forth, you might plot a graph. You might plot a kind of, chart to understand how these sales figure are growing from number 1, 2, 3 months, year, whatever it may be. So like that, you can predict the trend. We are not, fortune telling here. We are just extending the graph further. We are just portraying or try to say this is an approximation. And this mostly used in the weather predictions. The weather prediction, what we see on our, news channels, various, data services, it works on something called predictive analysis. Could you understand what is predictive analysis, ma'am? Could you give me an example?
Sorry, what?
Could you think of any example in predictive analysis we do on day-to-day basis or something like that?
Well, predicting, for example, using the GPS, right? You're predicting how you're going to get from point A to point B.
Great. And the graphs are plotted by the satellite and there's 3-point imaginary and all. That's really great example. Believe me, it's one of the
something very simple. Yeah.
Yeah, very simple.
Or maybe like a bank using like customer transaction history and credit score, like to predict whether they're going to miss a loan payment or something like that. Could that be a predictive analysis?
Definitely, ma'am. Very, very great say. And this can be, we can take it to a prescriptive analysis as well. Now, what is prescriptive analysis? Prescriptive analysis is building solution on predictions. So when you say
what happened, so
yeah, exactly. What happens and how we can prevent, let's say, fraud detection. How do you detect fraud? If somebody is depositing amounts for years together and one bright moment, he or she start withdrawing or big sums, right? So normally what happens, the bank's, database are basically triggered with such, changes happening in the database. So whenever we are trying to say Ravindra is depositing money like $1,000 per month or $2,000 per month, and at the end of third year, he have certain amount of, sums in his bank account, which is a substantial sum. And he just start withdrawing a big amount without informing bank or anything. So what happened? Bank will stop that transaction and bank will say, boss, you were depositing, means literally nowadays they call you, means whatever number you give to the bank, they call you and say, hey, Ravindra, are you okay? Any problem? Could we help you out? They try to, sound more of a preventive type of, tones, because that's their diplomacy in how to handle situation. But if Ravindra says, no, I have not withdrawn this thing, and this is a normal progression because you have certain, bank accounts where you store your money, right? Something like you save, it's for saving, right? So there you don't withdraw normally. Or if you're withdrawing, you might, tell the bank, boss, I want to shift this much amount to this much account for such and such purpose and all those things. It's not required by law to give purpose and all, but it basically helps to have these, things sorted out in terms of exceptional level. And this is how the fraud is detected. So fraud detection is a part of analysis. It's a part of data science solution as well. So that's why prescriptive analysis, and if you can give fraud detection, mechanism as an example, is one of the best example available for you. And it's simple enough, right? You can just give this, what I can say, example which I shared with you. Like somebody is depositing a certain amount which he or she's kept, for a rainy day, and one day he or she started withdrawing that. So bank will, trigger a database alert saying, hey, there's something wrong going on with this because I haven't seen withdrawal in the last, a good time. So now he or she is withdrawing. So there must be some problem. His account might get hacked or something like that. So this is what the fraud detection at its basics could be explained to anybody. Now there are various other ways and means have fraud detections, right? And it's a growing science nowadays in terms of data science. How do you detect fraud? How do you detect the account has been hacked, the card has been stolen, and blah blah thing? So that's the kind of fraud detection, intelligent thought processes, machine learning we implement in our banking day-to-day life. Does that make sense, ma'am?
Yes, it does. Yeah.
And this is the broad level, these four, different statistical categories we are going to learn and we are going to, understand in detail, right? So let me go ahead. Now, descriptive analysis. So let's try to understand the theoretical background and how we do it. What type of formulas, what type of different calculations we might include in descriptive analysis. So, descriptive analysis is a type of analysis that helps describe or show or summarize data points in a constructive way, such that the pattern might emerge that fulfill every of data.
Yeah.
Yeah, you want to say something?
No, I was just reading it. Sorry. Yeah.
Okay, no problem. Now I'm going to share the PPT, please don't worry. But here we are trying to understand in terms of what is descriptive analysis. So here we are describing the data in bullet points. As simple as that. This is the simplest form of data analysis we normally do. So these are normally given to the junior level data analysts and or the data analysts who are starting their job. So they might say, could you please summarize these sales figure? Could you please summarize this last 2 years regional distribution and profit margins and blah blah thing. So this is a kind of descriptive analysis. Now, as of today, I believe ChatGPT can do or can help you in descriptive analysis, or all these AI ML tools which are there, Copilot, ChatGPT, and all similar tools can do the descriptive analysis with a bit of complexity, but yeah, they could do it. So we could understand to have these descriptive analysis done by some automated processes as of today. Again, I'll say some automated processes because that's the fact, that's a kind of bottom line today. But there are some human insights still required. And that's how I feel. Again, this might be personal thing, I might be wrong, but the way I feel, there are certain human element which is required to be included in explaining these business numbers, business whatever things you are analyzing. There is a human element there where you try to understand if there are any exception, how to tackle those things. In mathematical terms, you can just find exceptions, but why these exceptions are there and how these exceptions are hurting or benefiting us in the business, that still has to be described, or that still has to be analyzed by the humans first, and then we could be able to explain it to the senior people. So descriptive techniques often include constructing tables, quality means, the methods, depreciations such as variance, standard deviations, cross tabs, and these things basically. Again, these are various terminologies used in descriptive analysis. Okay, again, measures such as segregations, discriminations, and inequality are studied using specialized descriptive technique. So segregation, you segregate, you separate out certain range of data, certain date range, a certain volume range, and so on and so forth. Discrimination, you try to discriminate the various mathematical status, mathematical columns available based on might be year, months, or something like that. Again, depending upon the categories you're considering, you can discriminate the data. Again, this is not the discrimination or segregation which we normally do in real life, but this is a kind of more of mathematical segregations or separation we are looking for. Again, inequality on the same way. We are trying to find exceptions. We are trying to find out of range. So if let's say to understand out of range kind of concept, let's try to understand. I normally drive my car within the speed limit. Max, I go up to 1 or 2 miles above speed limit. So if the speed limit is of 35, I might go to 36, 37. That's all. I don't go more than that. And this is my normal range. But sometimes if somebody is driving car at 45 speed in 35 speed limit. That's a kind of unruly behavior, or that's a kind of exception is happening, and that's why there are some speed sensors, some policing involved in such scenario. Otherwise, if you drive your car, nobody will disturb you, and so on and so forth. So there's a element of inspection here. There's an element of observation analysis here. Discrimination is measured with the help of audit studies. What is audit studies? If the processes are normals within range, go ahead. If there are some problem in terms of variation, in terms of exceptional highs or lows, we have to understand the reason behind it, and if that could justify the progression of a higher level or a lower level, and so on and so forth. So that's why auditory studies or mathematical audits are needed on these numbers or data, and there are various methods to it as well, like decomposition method. There are various periodic audits, and so on and so forth. Again, there could be, as these are mathematical mathematical processes, we might repeat it a number of times depending upon the criticality required, depending upon the observations. Recordings has to be done, and so on and so forth. More segregation on the basis of type, inequality of outcomes need to be wholly good or bad in itself. Okay, these are all, they're just trying to explain how could you analyze a given range of numbers, and so on and so forth. Okay, so there could be a prerequisite of understanding the processes in terms of the range. So if I'm driving my car within the range of let's say 30 to 37 miles per hour, that's my range of driving in a 35. I know the roads. I go by that road almost on a daily basis, be it something like home to office or home to supermarket type of road. But these are internal residential roads. Okay, so there we have a speed limit of 35 or 25. Again, depending upon the roads you choose, you might increase or decrease your speed. Again, but the normal legal rule is you can't go above and beyond 10% of the variation. So if you are in the 30 range, you can go up to 3 miles above the speed limit. 35, something like 3.5. So with the 35, I can drive up to 38.5 miles per hour. That's the max allowed by the normal policing. Again, depending upon the police, depending upon the implementation of law, there could be some stricter law implemented in a given area as well. So like if Martin Luther King's arrest was done by in a 35 range, he was driving 37 miles per hour and he got arrested. Again, there were debates, there were good amount of legal proceedings on that, but at the end of the day, he was performing an exceptions, going above speed limits, and this kind of things also happen in a real life. Okay, so that's a real life scenario I shared with you. Does that make sense, ma'am? Could you understand descriptive analysis?
Yes, sir. Yeah.
Okay, great. Now, there are various steps in descriptive analysis. These are all statistical steps. Again, you might start with measure of frequency. So how much, frequently you are doing it. So let's say if you're driving from your house to office, let's materialize that example into real world. You're driving, from your house to office. Your office is around, let's say, 10 miles. And you normally drive in an interstate road, which has 35 as a speed limit. And you started driving today. Today is your first day, so you are more cautious. So you are, driving at a 28, 29 miles per hour, and you are keeping a good tab of it. Next day, you might go faster, so 30 miles per hour, but still you are cautious enough. In the next month, you might, start going a bit of above speed limit, and this is happen as a human. So whenever you are going, in the 35 speed limit zone, if you're going above 35, there should be a alarm. There should be a a certain indication to you, like, okay, in these things you are going above and beyond 35. And that's in the new cars, you might find that thing happening, because they have all these GPS, the speed limits plots and everything included in the map. So map can clearly tell you, like, you are going above certain speed limit which is allowed in that given state highway. And these things do happen. Now, if this keeps happening continuously, then there's a matter of illegality to be resolved. There's a matter of aggressive tendency as is depicted by the driving laws. So we need to understand what type of aggression is this person is showing for driving. So how to tackle that? Then you might have a speeding tickets and blah blah things. Now this is what we call say measure of frequency. So for in a given month, how much time you are speeding beyond speeding limit? That's a kind of measure of frequency. Frequency is a number of times it happened in a given range. Range is basically, let's say from 1 to 100 is a range. So 1 to 30 in a month, that's the day or date range we have. 1 to 30, 31, 28, again, depending upon the months you choose, that's a range. Now, frequency is how many days you have sped below, over the speed limit. That's the kind of frequency we are looking for. Okay, and that's a frequency. Okay, let me, play you a good video, how we implement this thing in, Excel.
Okay.
Okay, and that will give you a clear. And I'll share 2-3 videos with you so that right. So these are all a bit of terminology which we need to either make it hard or write it down somewhere where you can explain. And mostly these guys have asked the types of analysis and what it contains. So what you can say, a simplest possible terminology. If you say in descriptive analysis, we are trying to describe what the data is. So we are trying to summarize. We are trying to trying to find the range, frequency, and all that'll be more than enough. But more or less in depth, that's what these guys have explained. And I'll share 2 more videos with you so you can understand in depth what is descriptive analysis is all about. Again, if you really want to go to a data scientist level, this is the kind of start we are looking for, right? So these are the kind of mathematician or scientists they do in terms of explaining the measure of dispersion, measure of positions, contingency tables, and blah blah things. Scatter plots are, as we discussed, we can plot a scatter plot in Excel. So all these things are available in Excel. There are few things might not be available in Google Sheets or anywhere else, but in Excel we have all these functions already mentioned there, and we could be able to do these things one way or the other. Okay. Now for that, there's another link I'm going to share with you where we'll have how to use input range and use a group by or outcome options there. Okay, even we can go to a level where we can do a k largest, k smallest type of understanding of group inclusion, group exclusion. Have you could you recall the mathematical groups, subgroups?
Could I recall the mathematical
groups, subgroups?
groups of groups? No, sir, I cannot recall like that.
Okay, let me get those things also. Basically, let me let me have those things. But I think these terminologies you can yearly know mean, median, mode, standard deviation, variance, range. Kurtosis, nobody have actually asked, but yes, range they've asked quite a few times. Standard deviation they've asked quite a few times. So these questions are really important in terms of how do you explain it to the interviewer in your terms. I have given here the theoretical.
Tell me something, sir. Is this part of data analysis or is this more like data scientist? Like, the mean.
This is data scientists. That's why I'm not saying all the things should be there, but these are
Yeah.
the basic 4-5 things which
Basic. Okay, got it. Yeah, the basic ones, right? Yeah.
This is the group by, subgroup by, and all those things. We'll see some applications also. But that's a kind of the data analysis going to the data scientist way, and there's no clear demarcation as such. Okay,
Yeah.
if they are paying you a bit more, right? So let's say 100K, 120K, they might want you to understand these mathematical terminologies, and they might ask in the interview. So this thing happens. We say advanced data analysis or senior data analytics for financial domain. This is a need. Means you have to understand the mean, medium, mode, outer range, inner range, and all those formula. How do you play in Excel? So this is the most complex thing. Believe me. So that's why I kept a pivot table XLOOKUP and VLOOKUP. These are the three things which have a basic mathematical understanding beyond that. That's why I kept it, for a later stage. And first we do these types, so we know where we use pivot tables, where we use the VLOOKUP and HLOOKUP kind of scenario. So that's why, this is basically getting critical and, basically getting complex. That's what I'll say. But yes, if you do these, first six, let's say mean, median, mode, standard deviation, variance, and range, that'll be more than enough. But you should do this by, either you can do it that paste-it way. So keep it in front of you or try to write it down a couple of times and that'll be more than enough.
Okay.
They have asked, how do you implement range in a given data set? As simple as that. Could you, explain how do you include range?
Sorry, say that again. How would I explain range?
Range in a data set. Let's say, like I told you, I have given that.
You mean range of data?
Right, range of data. That's very rightly said.
Okay, so range of data, well, it's like, the range is like the highest point to the lowest point in a data set.
Perfect.
Like the spread.
Yes.
The spread,
you got the answer, you nailed the answer, to be frankly speaking.
Oh, okay. So the spread, right? The spread is the range of data. Yeah.
Between the largest and the smallest value in a data set. So
Yes, yeah.
What's the range of salary? So that's what the salary of lowest pay, and highest pay, and so on. So that's very clear. Now, what are the standard deviation? Okay, let's do one thing. What's ahead of this? Okay, diagnostic analysis. Let's do one thing. Let me share this PPT with you. Okay, go through that and try to formulate your answer. These are the theoretical definition. Okay, and even I'll share a couple of video of diagnostic analysis. Descriptive analysis. Try to understand this thing in your own way rather than whatever theoretical given here and the big words and all. Okay, let's do that.
Standard deviation, okay, is a measure of. Okay.
Okay. What do you
Maybe
mean?
Like how dispersed the values are in a data set, like from reading it from,
you're very right. Like how the deviation is happening from the pardon me, from the middle figure to the extremes. How much is the deviation is really happening in a given data?
Yeah.
So it says the standard or typical difference between each data point and the mean. So how much a given data point is deviating from the mean point? Mean is the middle line of the data. So if the salary range from $10 to $100, the mean could be around 55, right? And I'm not doing any mathematical calculation here. I'm just sharing with you. So when I say how much a $30 deviated from that mean, or is deviation from the we might use average word in day-to-day life, but it's actually a mean. There's a bit of difference between average and mean, and we'll have a look at that also. But when I say if I'm getting a salary of $30, how it differs from the company's average salary? That's the normal discussion we do, right, in day-to-day life. So how much it difference? Oh man, the salary might be on a lesser scale. If you really talking as a layman. So how much less? Now I go to pen and paper or go to Excel and try to calculate. So from 55, how much that 30 is lesser? So that will give me a deviation for the salary I am getting from the mean or the average salary within the company. Could you understand the example, man?
No, sir. I was going to say, can you repeat it one more time?
Okay, definitely. Let's say in my company, there are employees who are getting salary from $10 to $100. It's just a kind of range or for the simplicity. Okay. So there's a person A who is getting $10 and there's person Z who is getting $100. might be per hour or something like that. Now, when I say my salary is $30, if you want to understand where do I stand in terms of salary range or in terms of average salary in a given company. So what I'll do, I'll calculate a mean. They'll give me a median line. So from 10 to 100, the median is 55 or 56. Either way, means or 55.5. Are you with me, ma'am?
Yeah, I'm trying to understand. Yeah.
Okay. Now, when I say 51.5 and I'm at 30, so how much deviation I'm looking at? So 50.5 minus 10. 50.5 minus 10 is my deviation. That much below I am on the average salary scale.
Okay.
Okay. So that's a kind of deviation I'm looking at on a given range. And these are basically kind of, understanding the variance and getting at a level. In the real world, in the mathematical world, the analyst use the measure of variability of the most frequently, and the standard deviation is the square root of the variance. Okay, again, that's a kind of what you can say derived mathematical formulae for standard deviation.
Okay.
We don't have to remember any formulas here. Just let me repeat that thing. All these formulas are inbuilt in the Excel. Okay, and we'll work on that. First, what I would really like to do, I'll stop here today because I know these are complex terms. Go through these things. Even Sahil should be present, but okay, no problem. So have a look at these things, and then we'll step into the formulas. Does that make sense, ma'am?
Yeah, sure.
Okay, and I want to do these at least two descriptive analysis, two analysis, diagnostic and descriptive with formulas, with mathematical formulas available in Excel, and then we'll go to the predictive and the prescriptive analysis. Okay, again the simplest terminology to understand these complexity progression in analytical types are. I don't know. My throat is also not working.
I know.
Pardon me for that. It's really annoying. You start with a basic descriptive, then you move to diagnostic, then you move to okay. Let me go to this thing so that you can understand better. If you can understand the progression today, that'll be more than enough. And then we'll go into the depth of all these four analytics. First two we need to check out how we implement in Excel also. But next two things are more or less they've never asked how to implement predictive or prescriptive analysis, but we should understand what they are. Okay, so descriptive analysis, you're trying to describe the mathematical figure or the data given to you. Diagnostic analysis, basically you're diagnosing it further. You are separating it by what I can say part by part, and you are presenting your findings to the business people. Predictive is basically you're doing a kind of trend analysis. So here you are improving your trend or you are extrapolating your trends. If you use the word extrapolating, that means you're just pulling the graph to extend to whatever you are as of today, and how will how will be on tomorrow or next week or something like that. So it's a kind of mathematical progressions beyond whatever we are studying today, if we have to have same continuous evolution. And that's kind of basic of predictive analysis. And then we have prescriptive analysis. After prediction, we prescribe. So if it's a positive outcome, how could you support those trend analysis? If it's negative outcome, how could we curb down the prescriptive analysis? How could we curb down the processes from going to positive to negative? So we should have a kind of let's say fraud detection is a negative of prescriptive analysis. Sales figure boosting for a given region, for a given product is a kind of positive example of prescriptive analysis. So if you could understand these four analysis types and think about an example, that'll be more than enough as of today's achievement. That's what I was. Does that make sense, ma'am?
Yeah.
Okay. And I'll share these presentations with you and those videos and the links so that you can understand in depth. Okay. Could we take a session tomorrow? Let me get that green.
Yes, we can do that. Yeah.
We can do that. Okay,
I
sure.
can do a session tomorrow. Yes, for sure.
Because then we can cover the other dias, analytics as well, and then
Sure.
we can take it up from there. Okay, so let me share these things with you, and let's meet tomorrow most probably, and mostly I think Sahil will be also. Okay.
Okay, sounds good.
Thanks.
All right. Thank you.
Thanks
Thank
a
you,
lot.
sir.
Good
Thank
night.
you.
Bye-bye. Take care.
Good night.